Hi friends, welcome on YourPedia, and this video is the solution of previous year's questions asked in Cochin Shipyard Limited for mechanical engineers. Cochin Shipyard paper is not difficult, one-liner paper, 40 questions, one-liner are asked from mechanical engineering, but there are some topics which are focused more than others. Like there is a lot of weightage of production engineering, material science kind of subjects, and practical related questions, practicality related questions. Like even if they are asking about Coriolis acceleration or Coriolis force component, they will be going into where its application is, quick return mechanism and shaper, something like that. So application based questions, and that is where you have to focus more. Now YourPedia, already you people are aware, has given you wonderful module friends for Cochin Shipyard for electrical and mechanical, and you need to prepare on that line. Every exam has its own requirement, so every CBT has its own requirement organization wise, and this Cochin Shipyard also has particular requirement, and you have to focus on that. So now I am telling you what questions were asked, from where the questions were asked. Maybe that will give you an idea to make a strategy for you. And in case friends you have not joined YourPedia so far for the preparation, you can start the preparation for the exam declared by Cochin Shipyard 28th January. This notification came. You still have time to fill the form till 20th of Feb. I can tell you that paper is predictable lines, so the kind of questions which will be provided to you in the module or kind of content will be provided to you, exam will be asked from there only. So let's start without wasting any time friends. So this is previous year's questions in Cochin Shipyard on the basis of 2025 exam. Okay, so read this question. It's metallic rod from heat transfer, and very simple question. Like metallic rod, the length of that is given, and there's a coefficient of thermal expansion alpha, there's a original length L0, and change in temperature. Now remember one thing here, delta T in degree centigrade or in Kelvin is same. So delta T 10 degree centigrade or delta T 10 degree Kelvin is same, because difference in temperature remains same in both the temperature scales. 0 degree 100 degree centigrade, 273, 373. So this is the freezing point, this is the boiling point, as you know. So 100 differences, 100 scale difference. That is one point you need to keep in mind. Another is coefficient of thermal expansion, which is given to you is per degree centigrade. So length was given and change in length was 1 millimeter. So another catch was you were to change it into meter, 10⁻³ meters. So the moment you put everything in place, so difference in temperature will be 50 degrees centigrade. So calculate the temperature rise in Kelvin scale. Suppose he says, even then answer is going to be 50. That was the question asked. Let's go for the next question. Coriolis component of acceleration. So Coriolis theory of machine, you study Coriolis. Coriolis acceleration always is observed on the body which is sliding on a rotating link. So if I give you here one link which is rotating, let us say this link is rotating at omega radian per second, and let us say there is a piston on this which is moving with velocity, sliding on this link with velocity v. Let us say this link rod is 1 and piston is 2. So piston 2 is sliding on rod 1 and rod 1 is rotating with particular angular velocity. So Coriolis acceleration is observed by this particular element. That is the basically concept. So Coriolis acceleration, component of acceleration exists if the body is sliding on a rotating component. So in the real world there are so many such example. I give you example of rotating earth and river sliding, water sliding in the river. River is a trajectory and water is moving, flowing here, and when the water is flowing and earth is rotating, this situation is created and there is a force acting on the river bed, and that is the reason after every couple of years river bed changes its position. That is how it goes. Similarly, there are so many engineering application friends. So this is the Coriolis acceleration 2 omega cross v. So there is a direction component involved. Omega is the angular velocity, v is the velocity of the slider related to crank. So quick return motion mechanism may we observe this. So answers you keep on seeing. So answer for this is when both sliding and rotational motion occurs simultaneously. So as you can see, this is a rotating OD is a rotating link, and P is piston is a sliding on that. So you understand that this link mechanism, it gives some kind of acceleration as is seen to omega cross V. Riser. So what riser does? Riser basically gives the molten metal, the reservoir of molten metal, so that if there is a shrinkage from liquid to metallic state, if there is a shrinkage in the mold, then that shrinkage is taken care of. So the rule here is riser should be so designed that the molten metal in the riser solidifies after the molten metal solidifies in the mold cavity. There is a mold cavity in the casting, you will pour the metal into that. So the metal in the mold cavity should shrink or should solidify first and then in the riser, so that riser can supply the molten metal in case there is a shrinkage, which always is there. So this is what the purpose of riser is. So that is the purpose. So you have seen the riser, right? This is a pouring cup and riser is there, and this is the mold cavity. You want to make this kind of shape. So riser will supply the particular molten metal when the requirement will be there in the mold. So that means many questions will be asked from riser, from this kind of gating design. So as I told you, there is a very high weightage of production engineering and of your material science domain, metal properties and all, and hence we have to prepare this very well. Okay, so now this question is from the bending stress. Bending equation, right? Very simple. M over I is equal to sigma over Y. So M sigma is equal to M I over Y, M over Z. So this Z is called section modulus. So I is BD cube by 12 and Y is D by 2. That gives BD square by 6. You understand? So it is inversely proportional. So if you see, sigma will eventually be equal to M over BD square by 6. So understand that. So it is sigma is inversely proportional to D square. So bending stress sigma. That was the question. So because it is inversely proportional to D square, answer is 4. Decreased by a factor. It will not be 1 by 4, it will be factor 4. Decreased by factor 4 means 1 by 4. Sigma 2 will be sigma 1 by 4. Okay, now this is from Vernier caliper concept. So least count of Vernier caliper, 25 division on Vernier scale matching 24 division on the scale, main scale. Main scale division is 0.5. So least count is the difference between one main scale and Vernier scale division. So main scale division is 0.5 given, already given, and it is given that 25 division on Vernier scale is equal to 24 division on main scale. So that means one Vernier scale division is 0.48 of main scale division. And what is the least count? Main scale division minus Vernier scale division. That is the least count. So this is a formula, some kind of basics. As I told you, we will cover it. We will cover it because we need to know, we need to explain this concept, what is the main scale division, what is the Vernier scale division, how this is, and what is the least count. So the topic here is least count. How to calculate the least count of these kind of small tools, that is a concept. So least count is main scale division minus Vernier scale division. Right. So this is the knowledge of the bearings, which we practically use the bearings, knowledge of the bearings, how we do, what are the different kind of bearings. So there are different kind of bearings, and what is the knowledge we need to have about various kind of bearings, right? So there are different kind of bearings. So this in gearboxes of automobiles, anti-friction bearings is used in the gearboxes of the automobile. Right, automobile gearboxes basically need to have very high speed, radial and axial loads are also there. So I want some this particular bearings which is asking for very high efficiency and very low maintenance. So anti-friction bearings, which are of ball and roller bearing kind, are used because very low starting friction and high precision is obtained. So in the automobile gearboxes, this anti-friction bearings. Anti-friction bearing is the concept where you make use of concept of the friction itself, like the friction is not basically creating any kind of trouble in some kind of maintenance issue or wear and tear issue. That is where, because this ball and roller bearings have very less friction actually because of the point contact. Lewis equation is important. It is used to determine bending strength of gear teeth, and gear tooth is treated as cantilever beam. So many times this question is asked when you are analyzing the gear tooth, how it is being treated. It is treated as cantilever beam. Load is acting, is traveling along the tooth profile. That is how the load is transmitted. Tangential load acts as the pitch point, so that we are to calculate the maximum bending stress. So what are the assumptions in Lewis equation? You must have done Lewis equation in gear design. So the assumption in Lewis equation is cantilever, we are assuming it, tooth is treated as fixed beam and free at the tip, root. So what is a cantilever and what is a tooth? Let me tell you that. This is what you have done, friends. One end of the cantilever beam is fixed and other end is free where load is applied. That is a cantilever, right? Now when you are talking about the tooth of the gear, let us say something like this, and when you are applying the load or force, if you see, it also is, this is the fixed end, this is the free end, and the load acting on that, something like that. So this is the first assumption. And tensile force is assumed to act as a tip, right? Radial components are neglected. So there is an assumption you should know, and you have studied that in machine design. When you study the gear design, you are to study that. So what magnesium does to cast iron? Magnesium creates spherodizer. Spherodizer means large size spherical shaped grains. When the grain structure is spherical, it imparts ductility and machinability. So ductility and machinability is high when spherical shape of the grain is acquired. When you add magnesium more than this, the cast iron it acts as a spherodizer, grain size gets in the larger size. Graphite is nodular shaped, pin shaped. So whenever grain is pin shaped, when the grain size is long, elongated, it is a small size grain. Whenever grain size is spheroidal, it is large size grain. Whenever grain size is large, it gives ductility and machinability to the material. But this size of grains, flakes or nodular shape, that increases the hardness or brittleness. Centrifugal casting. This is the shape, friends. Impurities will be towards the center because the weight of impurities are lighter in weight. So something which is lighter, the centrifugal force acting on that will be lesser and it will not go to the periphery, it will remain in the center, and it can be through drill very easily can be eliminated. So this is a typical centrifugal casting. Molten metal is poured from this pouring basin, molten metal, it rotates and heavier molten metal will go towards the periphery. So outside is very smooth, but inside there will be left these all impurities, and we can remove these impurities from the center because they are light in weight. So 4-stroke 4-cylinder reciprocating engine has cylinder diameter of this, stroke length this, clearance volume this. Engine capacity in cc is to be calculated. So we have bore, we have stroke, and this is the formula to calculate the swept volume. So as you know friends, there is a swept volume. Let's say this is a piston cylinder mechanism. This is the cylinder. So stroke length L, bore dia D, and this is the swept volume. Clearance volume is something where it does not go, that is V clearance. So swept volume is this. Bore dia is given, so swept volume can be calculated. So total capacity is 4 times the swept volume. So number of cylinders into Vs gives you the Cc, cubic capacity. So cubic capacity में हम swept clearance volume is not counted. So clearance volume is calculated only to calculate the compression ratio. When you calculate compression ratio, clearance volume also is accounted. So top dead center till the piston head is a clearance volume. Bottom dead center. So top dead center to bottom dead center is the stroke length, and multiply that with the area, bore area, that gives you swept volume. Coefficient of performance of refrigerator, what we are actually looking for and what we supply. So if you see the schematic diagram of refrigerator, this is the typical refrigerator. So this is work which is done, refrigeration. So this is the high temperature, low temperature. So heat is taken from low temperature to high temperature at the consumption of work. So what we look for, do we look for Q2 or Q1? So this is refrigerator Q2. So this is Q2 by W input is the coefficient of performance. For pump it is Q1 by W. So this is how it is calculated. That is Froude's number. Froude's number is used for open channel flow. So choking means maximum choking. आपके गले में choking. So if there is a choking in the throat, that means your throat is full. You cannot swallow more. Already it is full. So choking means it is already flowing full. So choking occurs when when there is already very high flow rate remains maximum. So even if pressure increases, flow rate is not going to change. So if you see the performance parameters of this compressor, you will find that surge is low flow, high pressure condition, due to which there is a reverse airflow, sphere vibrations. Choking on the other hand is maximum flow, where the velocities have already reached the sonic speed and further capacity cannot be increased, and it typically occurs at the impeller inlet. Speed of sound, mass flow rate reaches the maximum value and cannot increase further even if pressure ratio gets increased. Another name of choking is stone walling. So at the throat of, you can see this diagram also. So mass flow rate reaches maximum at the stage of choking. This is the choking limit, maximum flow rate point. Pressure ratio versus mass flow rate. Maximum mass flow rate, this is the choking. So welding defect, this is a typical welding defect. This is a base metal and molten metal. So when molten metal is not in position to melt the base metal, this base metal, molten metal is not in position to melt the base metal. This is a problem of the fusion, melting of filler metal and base metal, because of which there is a fusion can take place. Root face, side face, these are the terms. This is the side face, this is the root face. For 1841 high speed stool, 18 is tungsten, 4 is chromium, 1 is vanadium. So obviously this, you should know what chromium gives, what tungsten gives, what vanadium gives. So wear resistance, vanadium, red hardness, tungsten, corrosion resistance, chromium. 1841, you should know what sequence is that. Friction clutch, so that means clutches से question आएगा. Friction clutch, positive contact clutch. Positive contact clutch are called dog clutch. So jaw clutch is basically based upon jaws or teeth. So how you get the grip? Positive contact gives you grip. This is the positive contact, jaws. Can you see this grip, how it is obtained? In this case, this is the cone clutch mein friction. So see these two and you will find out how the grip will be obtained. So in the centrifugal, disc or cone clutch rely on friction between the two surfaces to transmit the power, whereas positive contact, which is a dog clutch or which is a jaw clutch, so these all depend upon the friction. These clutches depend upon friction, this does not depend upon friction. It depends upon the jaws or dog clutch भी बोलते हैं इसको. Yes, critical path. So whenever in PERT and CPM you go from initial node to final node, the longest path on the network diagram is the critical path. But when it is a longest path, there is no scope of further delay, and hence slack and float both are 0. Yes. It is the longest path. So statement 1 is incorrect. Longest path on the network diagram, but shortest time required to complete the entire project. Okay friends, let's go for question number 18. Now this question says if piece of material neither contracts or expands in volume, that means volume change is 0. There is volumetric strain. If volume change is 0, volumetric strain is also 0. Now see this formula friends, volumetric strain means epsilon V is epsilon x plus epsilon y plus epsilon z. So strain in x direction, strain in y direction, strain in z direction. So suppose I give you 3-dimensional view. So epsilon x, epsilon y, epsilon z. So epsilon x is strain change in x direction, but obviously this depends upon the y and z direction also. So this is volumetric strain formula in which 1 minus 2 nu comes. So if volumetric strain is 0, then 1 minus 2 nu is 0 and nu comes out to be 0.5, and that is for rubber. So that is from where you can calculate it. So don't just focus on what information is given, from where we have to calculate it. So some more information about Poisson's ratio. For most of the engineering material it is 0 to 0.5, and for rubber it is 0.5. That means there is a lot of lateral strain because of the longitudinal strain. So if longitudinal strain is 1, lateral strain is 0.5 in the negative direction. That is this, but volumetric strain is 0. When can a piezometer be not used for pressure measurement in pipes? Fluid in pipe is a gas, so piezometer cannot be used for gas, right? So if it is already gas, piezometer it's the simplest manometer. So suppose there is a pipe flow and you put piezometer in this is a liquid flowing. So level of liquid rise gives you in piezometer the measurement of the pressure inside. So if the liquid is flowing, liquid will come out, you can measure in piezometer. If gas is flowing, you cannot measure it. So yes, piezometer cannot be used for gas. Okay, so you know Cherepanov rule. This rule says that solidification time is proportional to square of volume to surface area ratio. Volume over area ratio, V over A ratio, whole square. So for cube also you calculate, and for smaller large cube, if you see for cube this solidification time is, volume is this is proportional to A by 6 is proportional to A square, A by 6 square, right, V over A. So for small cube and for large cube, from where ratio can be calculated. So you know this formula is to be used, volume over area ratio. So why Otto cycle cannot be used for turbine operation in turbine plant? Otto cycle is constant heat temperature cycle, constant volume heat addition. Otto cycle is constant volume isochoric heat addition and diesel cycle is isobaric heat addition. Isochoric, isobaric. So heat transfer at constant volume is difficult to obtain in turbine plant. So for internal combustion engine you can get it, but not for otherwise. Turbine plant operates on continuous flow process. So this is the Otto cycle, and the Otto cycle constant volume heat addition is given, but how shall you give that? How it is possible that heat addition is constant volume? Heat addition at top dead center. This is the bottom dead center. Top dead center, that means instantaneous heat addition. The piston is standing at top dead center and instantaneously you have given heat, that is top dead center. And instantaneous heat addition justifies how heat addition is done at constant volume. Now in the turbine that is not possible. Turbine is continuously rotating, so it is difficult to provide entire heat, and that is an open system. It is a closed, it is basically analyzed as a heat addition and heat rejection is closed system approach, but in turbine it is open system approach. So this is closed system, open system approach. Simultaneous motion cycle chart, what does it represent? Different motion of different parts of the body. Ergonomics also is studying this. Thermodynamics. There was a name of scientist Gilbert, reverse of that is Thermodynamic, who studied about how body parts move when you work. Hands are doing work, idle time to calculate when hand is resting and all. To calculate that, SIMO charts are used. It is micro motion study tool used to find out how much time is required for doing particular work. Micro motion, my hand is moving, my body is moving. So when you see that entire body parts are moving, you can calculate how much time is required in normal way to complete a task. That is this SIMO chart is studying. There are symbols, signs are given, and this is how it is calculated. Adiabatic process. Okay, so rack and pinion in shaper tool is very important. So how do you give reciprocating motion? Rack and pinion, all of you know. Rack and pinion mein rotary motion is converted into reciprocating motion. So in the shaper, the tool moves, reciprocates on the workpiece. So that reciprocating motion is given by rack and pinion. Yes, so what is flexural rigidity? That is EI, and section modulus is I over Y. So I just now discussed with you in the bending equation, M over I is equal to sigma over Y. So this M is equal to sigma I over Y. This I over Y is nothing but section modulus Z or Z. So section modulus actually it gives you maximum bending moment, or M a beam can withstand. So if sigma is the yield strength of a body, material property, Z section modulus is of the section, then what is the maximum bending moment I can resist? Maximum bending moment means sigma maximum, which is yield strength, and Z maximum, which depends upon the shape. Flexural rigidity on the other hand is related to this is measure of stiffness. Gearing contact. It is rolling as well as sliding. At the pitch point it is pure rolling because there is a point contact. Other point it is sliding. So understand that whenever two gears are meshing, that the motion, relative motion is both rolling and sliding. At the pitch point this is purely rolling, at other points it is sliding. Refractoriness is the property of that. Permeability is how gases can escape. Cohesiveness, basically ability of the sand grains to stick to each other. Adhesiveness, ability of sand to stick to the wall. So this is how. Refractiveness is high temperature. Total float. So floats are, let me tell you friends, there are different kind of floats. I give you one activity. Suppose this is one activity. This is the starting node and a node 2, 4, 8, 12. At the earliest I can start this activity at 2 minutes or 2 hours. This is the time. At the earliest I can start this activity after 2 days, right? Previous activity may be some another activity. So this previous activity will be completed latest by 4. This A activity is to be completed latest by 12 days. At the earliest I can start this A activity after 2 days, latest time to complete it by 12 days. So total float is the difference of this, and how many days this activity A is going to take. Let's say 2 days. So 12 minus 2, let's say 3 days minus 3, that is a total float. So what is total float? How many days A activity is going to take for completion? 3 days. At the earliest I can start A after 2 days. At the latest I am to finish it by 12 days. So 12 minus 2, 10 days I have. But total float, how much total float I have? I have total 10 days, in which 3 days I am to do job. So 7 days. Which of the following material is correctly matched with its common applications? Babbitt gives you journal bearings. So we'll discuss about this various materials and their applications. So bearings में Babbitt material. Archimedes number, this is the formula in which there is a gravitational force, friends. There is a density involved. Now this is the formula only, and viscosity involved. So viscosity, density and gravitational force. This is the dimensionless number which is used to determine motion of the fluids due to density difference. Arc is stuck between what in submerged arc welding? Consumable bare electrode and workpiece. The submerged arc welding, there is a bare electrode and that electrode will burn, and around it there are granular flux. That is, the electrode is submerged in the granular electrodes, granular flux. So continuously the bare wire electrode is consumed, and then there is a granular flux around this. So there is a granular shaped flux and electrode gets consumed. This is the bare electrode. So this continuously is fed, wire electrode continuously fed. This is how it is done. Morse test. Morse test takes care of indicated power and brake power. Multi-cylinder engines, indicated powers is calculated by cutting off the power of each cylinder. So in terms of that, we calculate the brake power, change in brake power. Doubled as the length, because stiffness is inversely proportional to length. Like whenever you cut the length half, the stiffness will increase. If diameter is not changing, that means it is the brittle material, and aluminum, copper and mild steel all are ductile material. These are ductile, whereas this is brittle. Brittle mein there is no necking, so there is no change in the diameter. No necking, no change in diameter. Brittle mein there is a this. Soderberg relation is very important when we are to use this in with factor of safety and fluctuating loads. So what is Soderberg relation? So Material subjected to fluctuating loads. This is the equation. Yield strength is used as limiting value. Alternating stress, mean stress, factor of safety. Fluid dynamics, cavitation number. So cavitation number depends upon what? Again, now you need to know the formula of cavitation number. So local pressure, vapor pressure and fluid density. These are the terms involved in cavitation number. So there are some formula based questions. Again, Johnson algorithm, shortest path problems, negative edge weights. So I'll say this is a little difficult category question, because if you have not done this Johnson algorithm, you will not be in position to solve. Little difficult, ticklish question. Perforating, die casting operation, parting, notching, perforating. Punching large number of relatively small holes in regular pattern is called perforating. Ventilation, perforation means ventilation. See these diagrams, perforation means this, ventilation ke liye we use it, notching means cutting at edge, lancing is this. So we have bomb calorimeter and throttling calorimeter, two calorimeters. Bomb calorimeter mein constant volume is kept. There is a sealed container, so volume change is not there. As you can see, this is a bomb calorimeter. Another is throttling calorimeter. Dryness fraction of the steam is calculated by throttling. Throttling is the process in which enthalpy remains same, and that is where dryness fraction we calculate. Yes, that is a formula, that is a basically definition of Fourier's number, dimensionless parameter, heat condension rate to rate of thermal energy storage. That is a formula of this. So friends, they are very simple questions, but yes, you should know what is the formula, and that is where Cochin Shipyard preparation is a little different. Like you should know from where the question is coming, and that is accordingly you have to prepare. Fine. So I hope you have understood from where the questions come. This was not a detailed explanation class. This was like telling you from where the questions normally come. Previous year's questions have come. For idea for you, mentors are providing you a lot of questions and explanation to solve such questions. Thank you.